Welcome to Polar Graphing 2. This is AppLab Math. Alright, if you don't have this code that's listed here, then you really need to go through Polar Graphing 1, which talks about how you write this code to get the turtle here to the turtle graphics to actually plot a point and go through the algorithm of polar graphing. What we're going to do now is we're going to take this code, make an abstraction, put it into a function so that we can actually graph an entire function all the way through angles from 0 to 360. Alright, here we go. The first thing we need to do to create our abstraction is to write a function. So these are in functions, and what we're going to do is we're going to take this function here that takes an argument, and I'm going to put it way up here at the top. Of course, we're going to need to retitle our function. I'd call it plot point, no spaces there, with capital P, and then the first argument is going to be r. We need another argument here, so you can click this right arrow button to make room for another argument. Next argument will be, of course, theta. There you go. Now we have a function here called plot point with arguments r and theta. What we're going to do now is we are going to abstract this code of putting the turtle in standard position, turning left, moving forward, drawing a dot, and then moving backward. We're going to take all of that code and drag it into our function so that we can call that function over and over again. So I've moved all of those blocks in here. Now the entire method for actually plotting a point is encapsulated in this function, so we can use it anywhere we want. Now what we're going to do is I'm just going to show you we can use it really quickly right here by calling that function. So we're going to drag this call function over, and we're going to call the function plot point, and then get one more argument here, plot it here with and I'm going to put in r theta in here, r theta, and then when we run it, reset and run, it'll actually go through everything and plot the point just as it did before, -50, 120. You can put in any values here you want now to practice. Okay, now let's graph the entire function, r equals 100 sine 2 theta. What we need to do now is actually write a loop to go through all angles from 0 to 360, maybe going by a step of 5, and we're going to need to do that by first setting theta back to 0. So first we're going to need from variables, we're going to need an assignment statement here. So we're going to drag over x equals, and this will be theta. And then we're going to go ahead and put in theta equals 0. That's going to reinitialize theta to 0. Now from our controls here, we're going to need to bring in a while loop. This is going to have a Boolean expression here, an expression that evaluates to true or false, and in there we're going to do while theta is less than or equal to 360. And the less than or equal to cannot have a space in between them. Okay, this will allow us to notice how AppLab makes the orange block here for you, theta less than or equal to 60. And then in this case now we're going to need to drag from variables again. We're going to need to bring in another assignment statement, put it inside our while loop, and then what's going to happen there is we're going to need to set r equal to our big equation. Now this equation will need to be typed in exactly as I have it here. So this is going to be your equation. R is going to equal 100 times math.sine, parentheses, and then 2 theta, and then times pi over 180. The reason we need to do that is because sine here is expecting a radian value, whereas theta is originally in degrees, so we need to convert that degree measure to radians by multiplying by pi over 180. And then when you click in here, it'll make those orange and green blocks for you, and you now have 100 sine 2 theta. Only 2 more steps now. We're going to take our plot point function call, and we're going to put it inside of our loop now so that we can plot all of these points while theta is less than or equal to 360, and we only need one more variable assignment statement. We're going to put that in there, and we're going to let theta equal theta plus 5. And then what's going to happen is we should be able to run. By going over here, you just click the run button, and there we go. The turtle is going out. This is where theta is 5 degrees, 10 degrees, 15, 25. And then when it gets to 30 degrees, that's up here. Watch when it gets to 45 degrees. It should be right here at exactly at 100. So this could be a great teaching moment. You can actually see the graphing as it's going on. If you want to, if the students don't want to take as long as they need to, they can adjust the speed down here to make it slower or faster. Going all the way to the hare here, from the tortoise and the hare, you could just get done immediately, and you can see what you have. It's fun to change the 2 to a 3 and see what happens. You can do so many different experiments so quickly. Changing the 100 to 50, what does that do? Make some predictions. Of course, it's half as wide there. Lots of really neat things can be explored now, and the students really enjoy being able to code the entire grapher themselves from a blank screen. I hope you enjoyed it. Please check the comments below for some optional extra credit features that you could add. The document's linked below. Thanks for watching.